Hello, it's Scott Manley here. Now, Infant Jones was asking, what is specific impulse? Now, he knows that specific impulse is a measure of the efficiency of a rocket engine, but probably wonders why it's measured in seconds, for example. So, in physics, impulse is the total amount of force applied to an object over time. So you basically take the force in newtons and you multiply it by time and you get this total impulse. Specific impulse for a rocket engine is the amount of force you get per unit mass of fuel you consume. And that's pretty easy again. But the reason why it's measured in seconds is if you go back to the early rocket developers in the German program, they, instead of using newtons, they would use kilograms of force. So a kilogram of force is basically 9.8 newtons because you multiply a 1 kilogram mass by the acceleration due to gravity at the surface of the Earth and you get basically a unit of force in kilograms. So if you were then, say, to figure out the efficiency of a rocket engine burning a certain amount of fuel, you would measure the amount of force measured, multiply that by the time the force was generated, and then divide it by the number of kilograms of fuel produced. And guess what? The kilogram of force and the kilograms of mass in your equation can kind of cancel out and you're left with seconds. And that's why it's measured in seconds. And this had a knock-on effect of being incredibly convenient when they started working with NASA, and the engineers there were used to using pounds of force and pounds of mass. So again, specific impulse could be measured in seconds and they could actually agree on something, which is a shame that doesn't work for everything because of course Mars Climate Orbiter was lost because of a confusion between imperial and metric units. There's one other thing that's worth noting is that if you want to figure out the exhaust velocity given the specific impulse in seconds, you just multiply it by the acceleration due to gravity, either 9.81 meters per second or 32 feet per second, and the seconds cancel out and you end up with a velocity, and that's what specific impulse is.